Everyone, welcome back. Today, let's go over an easy question that I just solved on my own a couple of minutes ago. This one is pretty simple, and so this is going to be a quick video. This one's called Divide an Array into Subarrays with Minimum Cost 1. And if you take a look at the constraints, the size of the array is really small, so we can use an n-squared approach. Doesn't look like many companies are asking this, and so let's go over it. So you're given an array of integers nums of length n as usual, integer list, integer array. And basically they want you to identify the cost of an array, which is going to be the value of the first element of a subarray. So, and then they ask you to divide the array into 3 chunks, and then find the minimum possible sum of these chunks. So that just means basically cut the array into 3 parts, and then find the smallest value that you get from essentially combining the 3 parts, or adding together the 0th index element of the 3 parts. This doesn't look accurate, so let's go ahead and code it up and I'll show you, because it's supposed to be 6, because you can do 1, 2, and then 3, 12. So the smallest one is supposed to be 3, not 12. And so let's go ahead and declare a result. Because we are looking for a minimum, we want to declare infinity, because nothing is going to be bigger, anything is going to be smaller than infinity. So let's go over nums from left to right. So iterating over every element from left to right. And let's declare a j pointer from I plus 1 to the end as well. So I is here, I is at 0, let's say j is going to be here. And then now we want to divide the array into 2 chunks, or into 3 chunks, so we're basically having like two pointers to cut the array. So let's call this first is nums of everything up to I, second is nums of I to j plus 1, and then third is nums of j to the end. And if first and second and third, let's go ahead and print them. And then you'll see what I'm talking about when I say that 1 and 2 and 3 is the smallest, because this picture doesn't really reflect that. And so now, okay, I missed that. Okay, it reflects it right here, but you're basically taking the first element of every single division of 3, and then finding the smallest sum. So then result is going to be updated if the sum of the first elements of each subarray is smaller than the historical result. And then at the end, we can just return the result, because we've made all combinations of 3 cuts of the array that we can. And given that all the arrays have elements and none of them are empty. So, okay. If result didn't change from the end, then return result. And this is supposed to be minimum. Oops, actually, we don't want to do that. This is supposed to be a minimum, right? As mentioned in the question. Okay, and there we go. So, yep, again, it says minimum possible sum, not maximum, so got to read carefully. Other than that, I think it's a pretty simple question. Hope you enjoyed, and stay tuned for more.